All right, so the next part of this unit that we are going to cover is going to be arithmetic sequences. And what you're going to have to be able to do for this one is you're going to have to know how to create a rule for arithmetic sequences. Um, it's really not too bad to do this, and we're only just going to go through maybe like a couple examples with this, and that's be it for this video. So this video should be a little bit shorter, but our goal or objective for today is we will be able to create a rule for arithmetic sequences. All right, so let's go ahead and just talk about what arithmetic sequences are, and then go over a couple examples. All right, so arithmetic sequences. So an arithmetic sequence is in an arithmetic sequence, the difference between consecutive terms is the same. Meaning, if I were to draw or write out a pattern, let's say 7, let's say 12, 17, 22, 27, and dot, dot, dot. The dot, dot, dot means that this pattern is going to continue in the same pattern until infinity. And if you notice, in between each number, we're just adding 5. So this is an arithmetic sequence because the difference between each number is the same, right? And this difference is called the common difference. So when we get a string of numbers, if we see that they're all have the same difference between each number, then we can refer to that as the common difference. And if each number has the same difference between each one, then we know it is an arithmetic sequence. Sometimes we might get a sequence that is not the same number in between, and that could then be a geometric sequence. But we're not going to go through that. We're only going through arithmetic for right now. So when we do this, if each number or if the difference between each number is the same, then we know it is an arithmetic sequence. And each term is found by adding the common difference to the previous term. So when we started with 7, since we know the common difference here was 5, we are adding 5 to it, knowing our next term is 12. We're adding 5 to it, knowing that our next term is 17. Then we add 5, knowing that it's going to give me 22. We add 5, knowing it's going to give me 27. If we wanted to continue this, we can add 5 again to go to 32, add 5 again to then go to 37, and so on. All right, so an arithmetic sequence is when we have a common difference in between, and we're simply just adding that difference to the previous term, and is giving us our next term and our number. All right, so now what we need to do is we now need to figure out how we can create a rule for this. All right, and we're going to now rewrite out another problem and talk about this for how we can create a rule. All right, but this is what an arithmetic sequence is. And now let's go ahead and talk about how we can create a rule, because I might ask you for what is the 100th term in this. And you don't want to have to write out 100 different times of adding 5 to the number. We want to be able to jump straight to it. And that's what we need to be able to do with a rule. So let's go ahead and go over that. All right, so let's say that we have this pattern here, 8, 12, 16, 20, 24, 28, dot, 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 meaning it keeps going in that same pattern to infinity. So first, when we get a pattern like this, we need to see, is this an arithmetic sequence? So we need to start saying, what is the difference between these numbers? Well, the difference between here, we would add 4 to get from 8 to 12, and we would add 4 to get from 12 to 16, add 4 to get from 16 to 20, add 4 to get from 20 to 24, and add 4 to get from 24 to 28. So we see that we have the same difference in between. So once we see that, we know that this is an arithmetic sequence. And now each one of these is referred to as a term. Right? And this will be our first term. This will be our second term. This one will be our third term, and so on. So our fourth, I'm not going to write the word term out anymore, our fifth, and our sixth. So if I ask you, well, what is the seventh term of this sequence? Well, since we already have that sixth number, we can just say, okay, well, 28 plus 4, we know is going to give me 32. So then we can say that our seventh term is going to be 32. But what if I ask you for your 100th term? We don't want to have to, like I said before, we don't want to have to count out 99 different numbers. So we can create a rule for this. And what we do is we first identify what our starting number is. So in this case, our starting number is 8, and we represent that by a sub 1. All right, a sub 1 means it's the first term in our arithmetic sequence for the a. And remember, when we write that subscript underneath at the bottom, all that means is it's telling us like it's identifying. So that 1 is saying it's our first arithmetic term. This one, if we wanted to say the second term, we can represent it as a sub 2, because it's saying the second term in our arithmetic sequence. So that subscript, as we did with our x1 and y1, is just a way of identifying different numbers, right? So we can start with our term. And then what we can do then is we can then add our difference. So when we figure out what our difference is, we can add our difference, and then we can say, well, how many times are we going to actually use this difference? Like how many times are we going to actually multiply this out? This is where it can get a little bit tricky, because if I ask you for your seventh term, what some people want to do is they want to say, oh, okay, well, we can multiply 7 by that difference, by whatever number term that we have. So if we do that, we then will say, okay, well, let's think about our problem. We have 8 plus 7, because we're looking for our seventh term, times our difference of 4. Well, 8 plus 28 gave us 36 and not 32. So let's think about this for a second then. If we want our seventh term, how many times are we actually adding our difference? 1, 2, 2, 3, 4, 5, 6. We're only actually adding our difference 6 times, not 7, when we're looking for our seventh term. And the reason is, when we start with that first term, we're not actually adding any difference to it. We're starting with that number. And then once we go from the first term to the second term, that's when we use our difference for the first time. So what we would actually need to do is, if I'm asking you for your seventh term, we then have to actually change this formula a little bit. We need to do whatever number term we're looking for, and we're going to represent that by the letter n, because we can say any term that we want. And we need to subtract 1 from it. And the reason is, if we're looking for our seventh term, we're only actually adding our difference 6 times, because we don't add it to that first number. That first number starts with it and it initiates it. So then we can do n minus 1 times d. And now if we plug this in, we said, okay, our first term is 8, so we can say 8. We're looking for our seventh term, so we can say 7 minus 1. And we know our difference is 4, so times 4. Well, 8 plus, now it becomes 6 times 4, which 8 plus 24 does give me 32. So you see, that is how we can set up a rule. It's actually not that difficult. And then what we just need to just do for this at the end is the way that we will say, like, so if I say, give me the 100th term, since we can represent whatever term we want, we just set this equal to a sub n, which means our nth term of our arithmetic sequence. So if I asked you to find the 100th term of this sequence, we would then say that, the a sub 100, meaning the 100th term of this, is equal to our a sub 1, our starting point, 8, plus our 100th term minus 1 times 4, because we're looking for our 100th term there. And then from there, we just go ahead and simplify. So a sub 100 is equal to 8 times plus 99 times 4, which 99 times 4 is going to give me 396. So a sub 100 is equal to 8 plus 396. So our a sub 100 is equal to 404. All right, so then that means our 100th term would give us the value of 404. So if we actually add it plus 4, if we actually add it plus 4 100 times, we would get to 404. And we obviously don't want to have to do that 100 times. So we want to be able to create these rules. All right, so I'm going to give you another sequence. I'm going to create one more rule, and then that will be it for this video. All right, so now for this one, and this is the last one that we're going to actually do for this. But it just says, example 1, write an equation for the nth term. So it means we're finding a rule for the nth term of the arithmetic sequence. So the last one we did, I'm going to write these numbers out just a little bit bigger. The last one we did, we were adding. All right, and remember, so when we see this dot, 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 it means that that pattern continues forever. So the difference between 14 and 11 is -3. So our difference doesn't have to always be a positive. We could be subtracting from each number as well. All right, so to write this rule, the first thing that we need is we need what our initial starting number is, and that's 14. And then we need to know what our difference is. In this case, it's -3. So to write this out, we would then say, well, our a sub n, meaning our nth term of this arithmetic sequence, is equal to our a sub 1 plus n minus 1 times our difference. All right, so now we just fill in everything that we have. So our a sub n won't change, because although they asked us to find a sub 50, the first thing we're asked to do is write a rule or an equation. So we need to write this rule out. So now we just need to plug in what we know. Well, our a sub 1 is equal to 14, so it's 14 plus n minus 1, and then we know our difference is -3, so we're going to substitute -3. All right, when we write these rules, though, we do need to simplify this as much as possible. So meaning, since this is being multiplied, we are going to multiply that in. So we can then distribute the -3 in, and we get a sub n is equal to 14 plus, well, -3 times n is -3, so this actually becomes -3n. And -3 times -1 is a +3. And then we would just continue to simplify. So a sub n is equal to -3n plus 17. All right, so that's how our rule will be written. We do want to simplify this as much as we can. because we can distribute that -3 in and we know how to multiply like that, you are expected to do that. So this would be our rule. So now it says find the 50th term. So we would then say, let me write this in a different color. Let's go ahead and just do blue. So we would then say that our a sub 50, because that's what we're trying to solve for, is equal to -3 times 50 plus 17. And the reason why we're not subtracting 1 when we do this is because we already distributed the -3 in, and it's that -1 is included within our problem here. So then our a sub 50 is equal to -150 plus 17, or a sub 50 is then equal to -133. And that will be our 50th term, would be -133. And just to show you that this does work, if we were to plug it back into this, just to show you the same thing, we would have a sub 50 is equal to 14 plus 50 minus 1 times -3. So then we would have our a sub 50 is equal to 14 plus 49 times -3. A sub 50 is equal to 14. Well, 49 times -3 is minus 147. And then a sub 50 is equal to, well, 14 minus 147 is -133. So you see it does still give us the same answer. So even though we don't see that -1 anymore, it's embedded within this equation or within this rule because we distribute this -3 and multiply it out. All right. So this is what we do for an arithmetic sequence. All right. I know we just went through this kind of quickly. We're going to talk about this more in detail in class, though.